Welcome back in this lecture of the vector calculus. Today I will prove some vector identities which are very important for the questions, and then I will try to solve few more questions based on curl and divergence. So we have the following vector identities. The first one is, so for that let us assume let u is the scalar function and v is the vector function. V, w are the vector function. Then your divergence of the first property, divergence of u of v is equal to grad u dot v plus u divergence v. So for vector I am just using this bar symbol, which means the vector notation. Then we have the curl of u b equal to, this is same as the first part except we will have cross in place of divergence. This is your second property, and then third property, divergence v cross w is equal to w dot curl v minus b dot curl w. Then the fourth one is curl v cross w is equal to, now curl v cross w is equal to your v dot b divergence w minus u b divergence w minus w divergence v. Then we have our w dot del of v, then we have v dot del of w. So this is your fourth property. Then our fifth property is grad of b dot w is equal to, so this is equal to b cross curl w plus w cross curl b. Then we have b dot del w plus we have w dot del v. So this is your fifth property. Then we have the sixth property as curl grad phi equal to 0. Then our seventh property is divergence of curl v equal to 0. Here phi is the scalar point function. Then we have the property divergence of curl v equal to 0. Then we have curl of curl v equal to curl of curl v equal to, this is equal to grad divergence v minus del square v. So let us prove these 8 identities with the help of the definition. So proof. So the first property is divergence of u, where you use the scalar function. I am using the definition. I am not going to expand the definition of divergence. I will use the definition in terms of summation. So this is equal to I dot del by del x of u. The definition of divergence v is equal to summation I dot del by del x of v. And then if you differentiate this bracket, then we will have del u upon del x d plus u d del v upon del x. Now this is equal to, okay, now here you consider our v is the vector, del u upon del x cannot taken outside this summation, so this is equal to I del u upon del x dot b. So we can write this first one like this, and for the second term u is independent of the summation, so we can take u outside, and then in the bracket we will have I dot del v upon del x, and you can see that this is your dot product between these two vectors. Now summation I del u upon del x is your grad u. So the first term is grad u dot b, and the second term is u, and this is the definition of divergence v. So we have u divergence v. So here we don't have vector notation. So the first part, divergence of u v equal to grad u dot b plus u divergence v. Now for the second part, just replace your dot by cross. So we will have cross, then we will have cross, and here we will have cross. So for the second part we will get del u cross b, then u summation I cross del u upon del x, and that will be your curl v. So I am not going to prove the second part. Then we have the third part, which is your divergence v cross w. Again use your definition. The definition is I dot del by del x of v. So we have v cross w. Now with the help of the definition of the derivative, this is equal to summation I dot del u upon del x cross w, then v cross del w upon del x. Now this can be written as I dot del v upon del x cross w, and the second part will be I dot, here we have cross, I dot v cross del w upon del x. Now let us interchange this dot and cross, and that is possible because we have this term as bracket ABC, and your square bracket of ABC equal to same as BCA equal to CAB. So this dot product and cross product can be interchanged. Similarly, we will interchange this dot and cross product, but before that let us write this A cross B as B cross A. So we will get minus sign here. So we have minus, then I dot del w upon del x cross b. Now let us interchange the dot and cross. So we have this term, then here we will have del w upon del x, and here we will have dot. Now the first term is equal to I dot del v upon del x is your divergence v. So this is equal to w dot divergence v, and here we have v dot divergence w. So the proof of the second part is, for the third part is this one, and the divergence of v cross w is equal to, so we have cross here again, so this is your w curl v and minus v dot curl w. So the third part is w dot curl v minus v dot curl w. Now the fourth part. So for the fourth part, we have curl v cross w. So again, if you want to solve with the help of this third part, then let us write curl here. So we will get curl v cross w. So we will have cross here. Okay. Now if you differentiate the bracket, then we will have cross here. Now this is your cross product. Again we have the cross product here. So again, as in the previous part, in the third part, let us interchange these two. So if you interchange them, then we will get summation I cross del w upon del x cross v. Okay. Now we have a vector tetra product. So with the help of the vector tetra product, we can expand this bracket. So your bracket A cross B cross C is equal to A dot C, then we will have B minus A dot B, then we will have C. Then similarly here, this is equal to A dot C minus, so this will become plus I dot del w upon del x dot v. So we have B. Okay. Now what is this I dot del? we can write this as, so this I dot del can be written like this. We can write it as I. This is your basically your I dot del into del by del x can be written like your, you can send this del by del x inside this summation. So this is basically like this, I del by del x dot w, and then at outside we have b. This term can be written like this, and this summation I del upon del x is your del, and so this is your del dot w. And then here this is the definition of divergence B, so this is your W divergence B. Again this is your, just send this del by del x inside this solution. So we have I del by del x dot B, and at outside we will have W. Now this is your divergence W. So we have V divergence W. Okay. Now this is equal to, now first of all let us write this term. So we have V divergence W, then we have W divergence B, then we have this term which is your grad dot W V, then we have this term which is your grad dot V W. So this is your proof of this fourth part, and you can see that your curl B cross W equal to V divergence W minus W divergence B plus W dot del or del dot W of V minus V dot del or W dot del V of W. Now let us prove the fifth part. So for the fifth part we have some calculation. So the fifth part is, let us take its grad left hand side, which is your grad B dot W. Now the definition of the grad is summation I del by del x of V dot W. So again use the definition of differentiation. So we have del B upon del x dot W, then next one will be I, and then we will have B dot del W upon del x. So we have these two terms. Now as we know that as A cross B cross C is equal to A dot C B minus A dot B C. So from here you can see that your A dot B C is equal to A dot C B minus A cross B cross C. So this is the value of A dot B C. Now here we have terms like this, A dot B C. Say this is your A, or just write this as A dot B, then we have C outside. So with the help of this, if you replace your A by V and V, the vector V by del W upon del x and C by I, then this is equal to, now this is equal to A dot C. So we have A means B dot I, then we have B, that means del W upon del x, then we have A cross B cross C. So B cross, then del W upon del x cross I. So we have this step. Okay. Now let's just apply the summation. So this is equal to summation B dot del W upon del x is equal to, now if you apply the summation here, then you can see that this is your B. Now we can write it as I del by del x, then at outside we have W. Now this second term will be your B cross del W upon del x, and summation is here cross I. Now what is this? You can take this B dot B outside because it is complete vector. So we will have some B dot summation I del by del x, and summation I del by del x is your grade. So this is your v dot del, because if you take this v outside, then we will have just b dot, and then we will have summation I del by del x, which is your del. So this is your v dot del, and at outside we will have w, and then this term, and this term can be written as, this is your I cross. So if you interchange these two vectors and just take this b outside, then we will have minus v, then interchange these two vectors, then we will have v cross, and this will be your I cross del w upon del x, and this minus minus will become plus. Now this is your I cross del w upon del x, which is the definition of curl v. So curl w. So this is equal to v dot del w plus v cross curl w. So this is your b cross curl w. Now this is the value of this part. So this is equation number 1. Now for the second part, you can see that the second part, that means this first part, can be obtained by just replacing your b and w. So if you replace b and w in this term, then you will get this first part. So let us replace b and w in this equation number 2. Again, interchanging v and w, we get, so if you interchange v and w, then we will get w dot del v upon del x I. So this is your this part, and this is equal to w dot del v del w cross curl v. So this is equation number 3. Now just put the values of equation number 2 and equation number 3 in equation number 1, and we will get the answer. So by 1, 2 and 3 we have, so by 1, 2 and 3 we get, so if you put this value here, then our grade v dot w is equal to b cross w curl w, then we will have w cross curl b, which is this term, then we have b dot del w, then w dot del b. So this is the proof of our fifth part. Now we have 3 remaining parts. So let us prove 6th, 7th and 8th part. So 6th part is equal to, so for the 6th part we have to evaluate curl grade 5. Although this can be written as del cross del 5. This is your del cross del 5. And if you take the cross multiplication, then you can see that it is exactly 0. But let us prove it with the help of the definition. So here we have to evaluate the curl product, that means cross product. So let us have the definition. You know that for the cross product we have the definition I, J, K. The components of del are del by del x, del by del y and del by del z. And the components of grade phi are del phi upon del x, del phi upon del y and del phi upon del z. So you can see that this is I into del 2 phi upon del y del z minus del 2 phi upon del y del z. So this is your 0. Then we have, you can write it as I, then in the bracket we will have del 2 phi upon del y del z minus del 2 phi upon del y del z. Similarly we will have the two term for example, for j we will have del 2 phi upon del x del z minus del 2 phi upon del x del z. So that means all the three terms are 0. So that means your curl grad phi is 0. So we can say exactly that del cross del of phi is 0. So your curl of grad phi is 0. So that means also know that if anyhow you can write if f is equal to grad phi, if your f is grad phi, then you can say that, then from here you can say that your curl of f is 0. So your curl of f is 0. And the vector for which we have this scalar function phi are known as conservative vector field. So for the conservative vector field, for the conservative force, we have curl f equal to 0. Now, so our next part is divergence of curl V. Again, we have to calculate the divergence of curl V. So before that, let us calculate this curl of V. So your curl of V, your next part is 7th part. So if you assume the components of V as B1i plus B2j plus B3k, then this curl of V will be I, j, k, del y del x, del y del y, del y del z, then we will have B1, B2, B3. And this can be written as I time del B3 upon del y minus del B2 upon del z. Then we will have minus j, so this will be your del B1 upon del z minus del B3 upon del x. And our next term will be k del B2 upon del x and minus del B1 upon del y. So we have curl V. Now we have to find out the divergence of this curl V. Now your divergence of curl V is equal to, now divergence stands for del dot curl V. So this del cross V. Again you can see that this is your A dot B cross C, and here you can interchange your dot and cross product. So you can see that you will get del cross del of dot D. So that means your this scalar product is exactly 0 for this divergence curl V. Now here we will prove this one with the help of the definition. Now we have to take the divergence of this, and divergence of a vector is equal to, say this bracket is say B1, say this bracket is B2 and this bracket is B3, then your divergence of B is equal to del B1 upon del x, del B2 upon del y, del B3 upon del z. So that means this is equal to, that means we will have to differentiate the first component of this vector x, then the second component with respect to y, then your third component with respect to z. And so this is equal to del 2 B3 upon del x del y. The first term is del 2 B3 upon del x del y. The second term will be del 2 B2 upon del x del z. Then we have del 2 B1 upon del y del z. Then our next term will be del 2 B3 upon del y del x. Then our fifth term will be del 2 B2 upon del z del x. Then we have del 2 B1 upon del z del y. As del 2 B1 upon del y del z is same as del 2 B1 upon del z del y, so you can say that all the 6 terms are cancelled with each other. So this term will get cancelled with this one, this is cancelled with this one, and this one cancelled with this term. So this is equal to 0. So your divergence of curl V equal to 0. Now our 8th part. So So the last part is curl of curl V. Okay, I have already evaluated the curl V, and now let us take its curl. In the seventh part we have taken the divergence of curl V. Now in this part we will take the curl of curl V. So first of all let us evaluate curl V. So we have this 8th part. Your curl V, again it is equal to I j k del by del x del by del y del by del z, then we will have d1 d2 d3. So this is equal to I del b3 upon del y minus del b2 upon del z, then we will have j del b3 upon del x minus del b1 upon del z, then we will have k del b2 upon del x minus del b1 upon del y. So this is your curl V. Now let us take its curl. So the curl of curl B is equal to, say, okay, now this curl of curl B will be equal to I j and k of del by del x, del by del y and del by del z. Now the first component is del b3 upon del y minus del b2 upon del z. Then the second component is del b3 upon del x minus del b1 upon del z, del b2 upon del x minus del b1 upon del y. And let us expand this determinant. So here I am taking just one component, that is the component of I, and similarly we will have other two terms. So let us write it as summation I. Now in the bracket we will have del by del y of this bracket which is your del to b upon del x, then minus del b1 upon del y, then you will have minus sign del by del z of del b3 upon del x minus del b1 upon del z. Now it is equal to, let us take del by del x common. So we can write it as, if you take del by del x common, then here we will have del b2 upon del y, and from here we will have minus del b3 upon del z common. So if you take this del b3 upon del x for this part, here we have the minus sign, so this will be a minus, and here we will have plus. So this is your minus, here we have plus, so this is your minus, and here we will have plus. So this del b3 is minus, and here we will have plus sign, so this will be a plus. Okay, then okay, we have only two components, so now just write other terms. Then this will be your del to b1 upon del y2, and this will be your del to b1 upon del z2. So we have terms like this. Now again let us add one term and subtract it. So I am going to add del to b upon del to b1 upon del x2. So this term is basically del to b1 upon del x2. So I have added this term, and let us subtract this term here. Now this will be equal to del b2 upon del y, del b3 upon del z. So this is our first term, and then here we will have, again subtract this one. So we will have del to b1 upon del x2, del to b1 upon del y2, and del to b1 upon del z2. Okay. Now this is equal to, this is your definition of divergence B. So this can be written as divergence B. So this bracket is your divergence B. Now, and then this is your then this is your summation I, and this is your del square V. So here we can write it as del square d1. This is your del square d1. Now this is the definition of summation I del by del x. So this is the definition of grad, that means del. So this is your grad divergence V. Then here del square is a complete component, so take this term outside. So we have del square. Now in the bracket we will have summation IB1, and summation IB1 is IB1 plus JB2 plus AB3, and this is your vector B. This was your vector B. So this is equal to grad divergence B minus divergence of B, and this is what we have to prove. So the proof of the eighth part is curl of curl B is equal to grad of divergence B minus del square B. Now let us prove few questions based on these identities. Although I am not going to use these identities, but we will prove independently. As I am not going to use these identities in our proof, so let us prove some important question based on the identity. So our first question is, show that divergence of R equal to 3 and curl of R equal to 0. So we have to prove that divergence of R equal to 3 and curl of R equal to 0. Then we will prove divergence of R cross A equal to 0, where my A is the constant vector, and then we will prove curl of R cross A equal to minus 2A. Your A is the scalar vector. Your A is the scalar vector. If you want to use, for the first two part, we can use the definition, and for the third and fourth part, if you want to apply these identities, you can. But I will not going to use these identities. So let us prove independently these four problems. So solution, the first part, your divergence of R. Your divergence of R is equal to, we can write, just use the definition of R, just use the definition of divergence, which is your del by del x of vector R. I dot del by del x of vector R, where your R is the vector xi plus yj plus zk. This is your R. And if you want to write this one, then you can write it here. So this is your R. Now if you differentiate this R with respect to x, now if you differentiate this R with respect to x, then you can see that this is equal to I cap. So we have this term equal to I dot I cap. So I cap dot I cap will be 1. Similarly, we will have two terms. The remaining two terms will be j dot j plus k dot k. So this is your I dot I is 1, j dot j is 1, and k dot k is 1. So this is equal to 3. So your divergence of R is equal to 3. And for the second part, let us find out curl of R. Now your curl of R will be equal to I cross del R upon del X. Now your del R upon del X is I, so we will have I cross I, and we can write it as I cross I, J cross J, K cross K, and this will be equal to 0 because your I cross I is 0. Now your third part, divergence of R cross A. Again use the definition. The definition of divergence V is equal to I dot del by del x of V. As your A is the scalar vector, so its differentiation will be 0. So we will just differentiate this R, and this is equal to I dot del R upon del x cross A. Again, as your del R upon del x is I, so we can write it as I dot I cross A. Now, as we can interchange the dot product and cross product, so we can write it as I cross I, and then we will have dot outside. Now, as your I cross I is 0, so this is equal to 0. So that means your divergence of R cross A is equal to 0. Now let us evaluate curl R cross A. So for curl R cross A, just replace your dot by cross. So we will have cross product here, and again we will have cross product here. So this is your vector triple product. Now for the vector triple product, just use definition. Now this will be your A cross B cross C. So this will be your A dot C. So we have A dot C into B minus A dot B into C. Now this is your I dot A into I. Okay. And this is your I dot I. Your I dot I will be 1. So we have summation A. So similarly we will have J dot J and K dot K. And let us prove the value of this term is A. I will prove it later on. And then the value of I dot I is 1. So this is your summation 1. And we have two more terms, J dot J and K dot K. So this will be your 3A. So this is equal to minus 2A, where your A is the scalar vector. Now let us prove that I dot A, I is equal to A. Because if your A is equal to A1I, A2J, A3K, then you can see that your I dot A will be, in that case your I dot A will be A1. Therefore, this summation I dot A, I will be equal to, now this your I dot A is A1, so this is your A1I. Now A1I can be written as A1I plus A2J plus A3K, and this is your vector A. So that means your summation I dot A, I is equal to vector A. So therefore, your curl of R cross A is equal to minus 2A. This was the proof of these 4 parts. Now let us solve some other question. So our next question is, show that for u x plus y plus z, b x square plus y square plus z square, and w xy plus yz plus zx. So if these are u, v and w, then show that these u, v and w are coplanar. Then show that u, v and w are coplanar. So here we have to show that these vectors are coplanar, that means they lie in a same plane. So solution, if you want to prove u, v and w are coplanar, then it is sufficient to prove that grad u, grad v and grad w are also coplanar. So this is same to prove del u, del v and del w coplanar. So let us evaluate grad u. So your grad u means I del by del x of this u. So this will be your I del by del x j del by del y plus k del by del z of this u, which is your x plus y plus z, and this is equal to 1 plus 1, sorry, your I plus j plus k. So this is your grade u. Then we have grade b. Similarly, our grade b will be 2xi plus 2yj plus 2zk. So this is your grade b. And then our grade w is equal to I times. Now if you differentiate this bracket with respect to x, then we will have y plus j, and then the differentiation of w with respect to y will be x plus z. Then the differentiation of this w with respect to z will be y plus x. So we have the values of grade u, grade v and grade w. We know that our grade of u or grade of v and grade of w are the normal vector to the surface. So we have three normal vectors. Now we will show that these three vectors lie in the same plane. So we show that grade u, grade v and grade w are coplanar. And for that we prove that this scalar triple product is equal to 0. So we will show that this bracket A, B, C is equal to 0. That means this scalar triple product is 0, and we can also write this scalar triple product as the component of del u was our 1, 1, 1. Component of del v 2x, 2y, 2z, and the component of w y plus z, z plus x, and then x plus y. So we will show that this is equal to 0, and now so let us take our left hand side. So your left hand side will be equal to grade u, grade v and grade w. So let us take this left hand side, and now we will show that this left hand side is 0. So that means these three vectors are coplanar. So just expand this determinant. So this will be your 2yx minus 2y square. Then we will have 2z minus 2z square minus 2xz. Then again we will have plus 1, then 2yz plus 2z square minus 2x square minus 2xy. Then we will have 1, 2xz plus 2x square, then 2y square minus 2yz. And you can see that all the terms are cancelled with each other. So we can say that these vectors are coplanar. So this 2x square is cancelled with this 2x square, 2z square is cancelled with this 2z square. Now here we have done a mistake. This is plus 2y square, this 2y square is cancelled with this one, and minus 2yz is cancelled with this one. So this is equal to 0. That means from here we can see that our grade u, grade v and grade w are equal to 0. So therefore we have obtained grade u, grade v and grade w equal to 0. So that means your grade u, grade v and grade w are coplanar. And if these three vectors are coplanar, that means your u, v and w are also coplanar. So u, v and w are coplanar. Thank you so much for joining this lecture.